One-click clustering. An educational video by EdgeADC. A load balancer, nowadays called an ADC, or application delivery controller, is a mission-critical component within your network. We do not pay daily notice to the ADC, and its criticality is very much under-acknowledged, but should it fail, traffic will not reach the application and data servers it serves. The business process could fail, and the organization could well incur customer and financial losses. So it must be shown the importance it deserves, by clustering it in the most efficient and easy to manage method. Clustering your ADC goes a long way to achieving best practice fulfillment within your business. Other competitive solutions in the market also provide ADC clustering. At EdgeADC, we believe strongly in delivering solutions that do not require specialist engineers to perform ADC configuration and maintenance tasks. So like all our other functionality, we have delivered what we believe is the easiest and fastest clustering system. The EdgeADC ADC can be clustered with a single click of the mouse. Once initialized, the clustering process will begin to replicate the primary to the secondary ADC. It will copy over the VIPs, virtual services, real server definitions, SSL certificates and associated assignments, persistence definitions, and other configurations. The master ADC is then in active mode, while the secondary ADC is placed in passive mode. The only item that the ADC cannot replicate is the apps installed in the ADC, such as WAF, GSLB, SSL Manager, etc. Each app is linked to ADC using its machine ID and has its own unique internal IP address. We want to make this demonstration as clear and informative as we can. We will have two ADC virtual appliances. The first, an active primary ADC, will have an IP address ending with 104. The second, an passive secondary ADC, will have an IP address ending with 105. We will have a single VIP and virtual service on ADC 104, with 3 web servers defined in the real servers section. We will perform a cluster creation and show how the ADC is replicated. We will follow this with a failover demonstration by powering down ADC 104, the primary cluster member. You will see how ADC 105, the secondary, will promote itself and become the primary serving ADC. We will also show you how to manually promote ADCs in the cluster to perform maintenance tasks. Before we show you the actual demonstration, the following slides will show you a pictorial representation. Here, we see the ADCs in an active-passive cluster, load balancing 3 real servers. In this particular case, these are web servers. Should the currently active node, 104, become non-operational, the secondary, passive node, 105, will become the new active ADC node. Since the VIP's IP address is the same, there will be no interruption in data flow to the real servers. The heartbeat and sync signal between the ADC nodes ensure this handover is smooth and very timely. The old active ADC can now be taken offline, corrected, and brought back online within the cluster. It will then assume the role of a secondary ADC node. Let's now see the clustering in action. On the screen, you can see the main IP services section of ADC 104. You will note that we have a single VIP, 192.168.159.115, that has been configured to use secure port 443, and is running the HTTP virtual service type. Below this is the real servers section, and contains 3 servers, 192.168.159.200, 201, and 202. All are configured to use port 80, showing that we are running SSL offload. We will now open a connection and browse to the second ADC, with IP address ending with 105. As you can see on the main IP services page, there are no entries present. 105 is a fresh ADC, a blank canvas. Back to 104, and we will proceed to the System section within the navigation panel. Now, click on Clustering. There are 3 sections within the clustering page: Role, Settings, and Management. The role section lets us choose how the ADC behaves in terms of clustering. Cluster is selected when you require the automatic clustering option, with high availability in active-passive. This role uses auto-synchronization of the appliances. Manual is also a high availability mode, offering both active-active and active-passive operational methods. However, in this mode, it is up to the administrator to configure both ADCs independently. Standalone mode is just that, with each ADC acting independently, without high availability. The settings section allows the administrator to set the failover latency time in milliseconds. The management section is where you set the clustering, and which ADC will be active or passive. As you can see, there are two segments to this section, with a cursor pad in between. On the left are unclaimed devices that are available for adding to the cluster. You can see that we have ADC 105 waiting to be claimed. On the right are devices in the cluster members. ADC 104 is already present as a cluster member. To join ADC 105 to the cluster, you highlight the entry and click the right cursor button, or you can also drag and drop the ADC entry from the unclaimed panel to the cluster member panel. The cluster has been created. It's as straightforward as that. If we now look at ADC 105 using the browser, we will find that the settings and configuration have been successfully replicated from ADC 104. What you have now is a fully functional, high-availability ADC cluster. The purple indicators show that the services are in standby mode and will take over instantly in the event of a failure of ADC 104. To change the order of the cluster, in other words, make 105 the primary active, let's take a look again at ADC 104. We are again at the clustering page, and you can see the two ADCs, 104 and 105 as cluster members. All you need to do is highlight the one you want to promote, and click the up arrow button. ADC 105 will be moved to the primary position, and will become the active ADC, while ADC 104 will be demoted to become the secondary passive, and its services will go to standby. This concludes our demonstration on one-click clustering of the EdgeNexus EdgeADC. We hope you have enjoyed our knowledge share, and thank you for listening and watching this video. EdgeNexus, the home of affordable, easy-to-use load balancing.